Hi, good morning to all of you. This is Venkatesh. So, in this video, I can explain about Y parameters from the two-port networks. So, from last video, we seen Z parameters. So that is nothing but impedance parameters. So here we discuss Y parameters. That is nothing but admittance parameter. So these admittance parameters, as this I explained as a similar way to the Z parameters. So here the network, it consisting of two ports, that is two pairs of terminals, that is 1 dash and 2 dash. So V1 and V2 are the voltages, that is input and output voltages. I1 and I2 are the input and output currents, and the I1 and I2 may enter to the network. And here I am writing that, so a function, that is I1 and I2, a function of V1 and V2. That means I1 equals to Y11 V1 plus Y12 V2, and I2 equals to Y21 V1 plus Y22 V2. So here, so I1 I2 are dependent variables and V1 V2 are independent variables. So that equations can write in matrix form y11 y12 y21 y22. This is the Y matrix, that is nothing but admittance matrix. So this admittance is nothing but reciprocal of impedance. So you can remember, reciprocal of impedance is nothing but admittance. So that is 1 by Z equals to Y. So this Y parameters is a dual of Z parameters. So the calculation of this Y parameters, so we are simply minimize the equations. That means you can minimize any one of the value from the above equations. So we should know, we should calculate the y11 y12 y21 and y22. So y11 equals to, so for calculation of Y parameters, I am taking first case V2 equals to 0. What I am doing that, V2 equals 0. V2 equals 0 means there is no voltage. So under the short circuit, there is no voltage presence. That's why I am taking the first case V2. That means output voltage is taken as 0. So the output voltage is taken as 0 means the short circuit presence at output side. So that is Y11 equals to I1 by V1 from the equation 1 at V2 equals to 0. That time the V2 equals to, that is a short circuit. So I by V is nothing but admittance. So short circuit, this 1 is going to be input parameter, that is input terminals. That's why short circuit input admittance. What I am writing that, short circuit input admittance. Where similarly, so at V2 equals to 0, from the second equation, from the I2 equals to Y21 V1. If V2 equals to 0, Y21 V1. That means Y21 equals to I2 by V1. So at this case, I2 is what? Reverse direction of current. I2 is the reverse direction of current. And what I am doing here, short circuit at the output terminals. That is short circuit. Short circuit. The current is going to be reverse transfer. So that means here, so in this, so I2 by V1, that is a short circuit forward in the case of first equation, first step. So that's why the current is I1 is forwarded, that is a forward transfer admittance. What is the short circuit forward transfer admittance? Similarly, you can take, so second step, second case, if V1 equals to 0, what I'm doing that, V1 equals to 0. V1 equals to 0 means what? The first 1 dash is going to be short circuited. So if 1 dash is going to be short circuited, so in the first equation there is a I1 equals to Y12 V2. So that means Y12 equals to I1 by V2 under the V1 equals to 0. So here it is calculated. So from Y12, so in this case it is a reverse transfer admittance under the short circuit output. That is short circuit reverse transfer admittance. Short circuit reverse transfer admittance. So reverse transfer admittance at V1 equals to 0. V1 equals to 0. And then Y21 next, under the same case, V1 equals to 0, Y22 equals to I2 by V2. So I2 by V2, 2. That means output terminals. That means output. I by V is nothing but admittance. So output admittance. So at V1 equals to 0, that means short circuit. That's why it is called short circuit output admittance, short circuit output admittance. So the equivalent circuit, so here all parameters, that means current, so I1 is calculated. So I1 is nothing but sum of the currents. So here the I1 is nothing but calculated sum of the currents. So that means for the KVL, I1 equals to Y11 V1 plus Y12 V2 and Y12 V2. Similarly, in the second case, so using the KVLs, so I2 equals to Y22 V2 plus Y21 V1. So it is a KCL. It is the equivalent circuit for the Y parameters. So Y parameters. Okay. So Y parameters is also similar to Z parameters. So here the main important things is this equation, that is I1 equals to Y11 V1 plus Y12 V2, I2 equals to Y21 V1 plus Y22 V2. So, and then the parameters. So for calculation of parameters, you should take the V2 equals to 0 at one time and V1 equals to 0 at another time. So this Y parameters can also explain by using a problem. So here I am taking the same problem for the what I am taking for the Z parameters, and the same problem I am taking here. So that is the circuit. So it consisting of two ports. So for calculation of Y parameters. So here the first case is taken V2 equals to 0. That means what? 2 dash is going to be short circuit. At that time the figure A shown like this. So at this case, so actually I2 is taken in this direction, but we are calculating the I2 in this downward direction. That means it's going to be minus I2 in the short circuit current, and V1 is the input voltage. One is the input voltage. So for short circuit current, minus I2 is nothing but what? Here the current passing here. So this current, that is minus I2, equals to the current entered to this node, that is the total current, into opposite resistance by sum of the resistances, that is a I1 into 2 by 2 plus 2, that is calculated like here. And then the total current I1 equals to total voltage V1 by RT. So where RT equals to, so in this circuit, so when we shorted the two dash terminals, the total current can pass into the short circuit. That means the 4 ohm resistor can going to be, the 4 ohm resistance is going to be minimized, that is 0. There is no current flow. That's why 4 ohm resistor is should take removed from the circuit. That's why I am getting this circuit. Okay. So here the RT is equal to, so from the figure A, so from the backward 2 and 2 is parallel and series to the 1, then I am taking as 1 plus 1, that equals to 2. The total current entered to the circuit is I1 equals to V1 by 2, that is I am getting 0.5 V1. So from Y11 is nothing but what? Y11 is nothing but what? I1 by V1 at V2 equals to 0. So I1 by V1. I1 value is nothing but what? 0.5 V1 by V1. That is 0.5. So it is a reciprocal of resistance. That's why we can take mhos. The unit says mhos. Coming to second one, Y21 equals to I2 by V1. So I2 equals to what? Minus I 0.5 I1. So I2 equals 0.5 I1, and V1 equals to, so V1 equals to 2 into I1. So you can substitute the values and I am getting this minus 0.25 ohms. This Y1 and Y2 is calculated from figure A. That is the main thing. That means in the from the first case. And take a second case. Take the second case. If V1 equals to 0, that is what? 1 dash is short circuited. 1 dash is short circuited. The 2 dash is normally connected to the source. So at that time, at 1 dash, the actual current direction is in the forward direction like this, but here the short circuit current is minus I1. So for the calculation of I2, so the I2 is nothing but what? The total current entered to the circuit. So that's why total current I2 equals to total voltage V2 by total resistance. So that RT is calculated here, that is a 1 parallel to and then series to the 2 and then parallel to the 4. So then I am getting the resistance of 1.6. So for calculation I am getting the 1.6 and that is substituted here. So then 0.625 V2, see I2 equals to like this. And then what is the short circuit current? So how to calculate the short circuit current? That is minus I1. So that minus I1 is nothing but what? The current leaving from the node 2. So current leaving from the this node. That means what is the current enter this node into opposite resistance by sum of the resistances. So that's why the current here I am taking as Ix. There is a current passing to the 2 ohms. So that is Ix into, so Ix into opposite resistance of 1 ohm is 2 by 2 plus 1. That is the equation number, so some 1, equation number 1. So then calculate the Ix. So how to calculate the Ix? So that's why, so for calculation of what is the total resistance, so using the current division rule here, and I2 equals to the opposite resistance 4 by, so total current is I2 into opposite resistance 4 by sum of the resistances. That means 2 plus 2 plus, so here 1 and 2 are going to be parallel, that is 0.67. so 1 and 2 is going to be parallel, that's why 0.67 plus 4 plus 2, that's why we are getting I2 into 0.6. I2 equals 0.6. So Ix equals to I2 into 0.6. So therefore for calculation of minus I1, for calculation of minus I1, so that is what, so I1 equals to Ix, I1 equals to Ix from equation number 1, Ix into 2 by 3. So Ix into 2 by 3, so that is what Ix, Ix into 2 by 3. So Ix equals to 0.6 I2 into 2 by 3. So that's why minus I1 equals to 0.4 I2. So therefore, so from figure B only we are calculate the y12, that is I1 by V2, that is I1 value is minus 0.4 y2, I2 into RT is nothing but V2, so that is minus 0.4 I2 by 1.6 I2. So therefore we are getting the 0.25 mhos. And similarly y22 equals to I2 by V2, that is a V1 equals to 0, that is 0.625 V2 by V2. So that is Y2 equals 0.625 mhos. So therefore the Y parameters in matrix form Y11, Y12, Y21, Y2. So here 0.5 from the Y11 from the figure A, and Y12 minus 0.25, Y22 is also minus 0.25, 0.625. So here also Y12 equals to Y21. That means it can satisfy the reciprocal, that means reciprocity principle, can satisfy the reciprocity principle. Okay, this is the two-port networks under this Y parameters and Z Y parameters. Thank you to all.